Okay, see Lindelof videos. Today we're going to be trying to find the intersection of a line and a circle. The problem that we're going to actually be working on today is find the intersection of the line y equals negative 3x and the circle with the center at 0, 0 and a radius of 1. And hopefully you can see here that they did not give us the equation of this circle, so we need to find this. Right, how about I just say it? Need to find the equation. So this is what I want to talk about first, is that there are some possibilities. There are only 3 possibilities here, and it's really important to realize this, because when you do your computation you might go, holy crap, what the hell is that? If that's what you're saying, then you need to go back and explore which of these possibilities you found. The first possibility is that the line doesn't pass through the circle at all. It passes over it or whatever, but it doesn't pass through. So that's a possibility. This is not unlike a line and a parabola, right? The second possibility is that you have one intersection, and keeping in mind if you have one intersection, you have a line tangent or a tangent line, however you want to best describe that for yourself. And the last possibility is that you have 2 intersections, and I think that's the case that we have today, and we'll talk about how to get that done. So 2 intersections. So the possibilities are 0 intersections, 1 intersection, and 2 intersections. So let's take a look at this just for a second, and I just want to look at the computational part of this. So this is going to be the computational part, and this is how we would grind this out. Remember that it's best not to estimate values. So if you get the square root of a number like 10, well, we don't know the exact square root, right? It could come out to be some dragged out decimal, so it would be better to leave it in that form. So that's what we're going to look at today. So we're going to find the intersection. The first thing we have to do, and I tried to allude to it at the very beginning of the video, is that we have these 2 equations, but we have to find the equation of this circle. Remember, circles are not functions, but we have to find this equation, and we have a circle that centers at 0, 0 and has a radius of 1, and that tells us something. It tells us that our function takes the form of x squared plus y squared equals 1 squared, and of course 1 squared is just 1, so we don't have to deal with this 1 here. We just square it, so that's already squared. So here's our equation of our circle. Now we have a function, so let this be equation 1. Let our next one be equation 2, and equation 2 is given to us as y is equal to negative 3x. So all we're going to do is the same thing we do when we're solving linear systems, or when we're solving a system of a line and a parabola, is that we're going to substitute one in for the next. And the way I want you to look at that is this. This y right here is this y right here. So I'm just going to substitute this y equals negative 3x right here. I'm going to put this right here. And remember, y is negative 3x, so that's this y right here. So that's all we're going to do. Pretty quick, pretty easy. We have x squared plus, look at this for a second, we had our y squared here, so here's our y squared is equal to 1. But we know, because we just looked at this, we discussed this, that this negative 3x goes in here. I would also caution you to remember the quotient rule. It's not the quotient rule at all. It's the power of powers rule of exponents, I believe, and that just reminds us that exponents are distributable across multiplication. So what we have is, we end up with, when we put our 2 equations together, we get x squared plus negative 3 squared is 9, and x squared, without being a whatever, is 9x squared is equal to 1. So next thing we're going to do is grind this out a little bit. X squared plus 9x squared is 10x squared, right? 10x squared is equal to 1. That's just me simplifying. I'm going to divide, obviously just do my simple algebra here, divide both sides by 10, leaving us with x squared is equal to 1, over 10. Look, we're going to take the square root of both sides. Square root here, square root here. So remember, when you take a square root, you take an even root, you end up with plus or minuses. So we get x is equal to negative, oh look, let's do this quickly too before somebody freaks out and be like, Dr. Lindelof, what did you do here? 10. Square root of 1 is 1. Square root of 10, let's leave it as the square root of 10. I don't know if your professors expect you to rationalize these square roots or not. I'm going to leave it to your professor to tell you if that's what he or she expects you to do or not, but gives us negative, this is x, whoa, this should just be x here, right? It should be x is equal to, so I'm going to just take this, I'm going to do 1 over square root 10 after I simplify the way I described here. And if that's true, if this is x sub 1, then y sub 1 would equal negative 3. I'm going up here. I'm taking this function up here, negative 3x. So negative 3, here's my x value, but we have x is 1 over square root 10. So this is our y sub 1, x sub 1 point. The other point we would get is our x sub 2 point, our second point, would equal negative 1 over square root 10, and therefore y sub 2 would equal negative 3 times negative 1 over square root 10. You can simplify all this stuff out. After this, it just comes down to algebra, so I'm not going to grind out all this algebra 1 with you, but here it is. So what we did was we found the intersection of a line and a circle. We talked about the possibilities. We talked about the fact that it's possible that there are no intersections. It also is possible that we have only one intersection. That would be a tangent line or a line tangent to the circle, or that we have two intersections, and that's our case today. And I'm not saying it does this because that's not what it would look like, but here's how we ground this out. So I hope this video is helpful. I'm actually going to do two more. I'm going to do one more computationally, and then I'm going to do two using the ti-nspire CAS calculator, using its solving function, and it makes it really easy. So you can look forward to that. Hey, thanks for watching. If you haven't already subscribed, please do. Appreciate you.